let's go ahead and take a look at the energy of chemical reactions. All chemical reactions are either endothermic or exothermic. So let's go ahead and take a look at the difference between the two. An endothermic reaction is where your reaction is actually going to get colder. And an exothermic reaction is the opposite. An exothermic reaction is when the chemicals are going to react and your product is going to be warmer than it was when you first started. So the heat is going to be given off in an exothermic reaction and absorbed in an endothermic reaction. So let's go ahead and take a look at a few examples of these that we're going to be doing in lab. I'm going to turn the laptop here so you can see the materials that we're going to be using. The first one is called elephant toothpaste. Some of you have probably seen this before, but let's go ahead and take a look at it in terms of being endothermic or exothermic reactions. So in the bottom, I have some of my chemicals already there, but I do want to make it just slightly multicolored. So I'm going to add a little bit of blue to our flask and just a dab of red going down either side. So you can kind of see them drizzling down the side there. The next thing I'm going to do is add our catalyst, which is a sodium iodine solution. So I'll go ahead and add that now. And again, these are going to begin to mix slowly, and it's going to start to get a little foamy at the bottom. Now, at the beginning of the experiment, and I'll just swirl them around just a tad so they begin mixing. Right now, both of these combining to make our solution here are basically at room temperature. Okay, and again, our goal of this is to determine whether this is going to be endothermic or exothermic, and sometimes that takes a moment. So as you can see, they're starting to really react with each other. It's going to get real foamy, and you can see it here in the middle. And I will tell you that the flask is starting to get just slightly warm, and this is going to come out the top eventually here. And there it comes. And if you look closely up here, there's definitely a little bit of steam being produced. Yeah, this is getting foamy. It's still going. Again, we got a couple colors. We got that red, that blue color is around this other side here, and it's still going. Yeah, it's definitely getting very warm. A lot of suds. It just keeps on coming and coming and coming. And what's actually being produced, and again, a good indicator of a chemical change is a new substance, and that new substance is a gas. And that's hydrogen gas. So if I was actually, and hydrogen gas is highly flammable, I'm going to go ahead and light this up. I got a wooden splint here and kind of put it into our bubbles. You can kind of see it lighting up. I can even blow it out, and sometimes it will come back on. There's so much hydrogen gas here. Watch, it's out, and I'll see if I can get it back on. Yep, there it is. So hydrogen gas being produced. I'll just drop that in there. All right, so again, very warm now. You can hopefully see a little bit of the steam occurring with that. And the pan itself down here at the bottom, very warm as well. Okay, let me just slide this off to the side here. All right, let's go ahead and take a look at our next one. Our next one is with some hydrochloric acid in our test tube right now. And let me give you the temperature of that. And it is currently at 22 degrees. I'm going to drop in my piece of magnesium into the acid. And it's bubbling away vigorously. I'll put the thermometer back in, and I'm going to kind of show you what's going on there. A lot of bubbling, effervescing. So another good chemical reaction, a good indicator of a chemical reaction is bubbling. Again, another good indicator of a chemical reaction is light or heat being produced. So again, our original temperature was at 22 degrees, and again, it's still bubbling away in here, as you can see. And our new temp, you can see that. Yep, we're currently at 31 degrees. We'll let it react for just a little while longer. So again, heat at this point is being produced from our chemical reaction. The magnesium is just about done boiling, or excuse me, bubbling away. And it looks like it's done. And our final temperature is at 38 38 degrees, 38 degrees. So we went from 22 to 38 degrees, so a plus 16 change in temperature. All right, our last one I want to take a look at is using two different types of salt, not sodium chloride, what you would eat on your French fries, but this is lithium chloride and potassium chloride. And I have everything measured out already. So what we want to do is get our initial temperature of each one. Okay, so let's start with the lithium chloride and our water here. And our initial temperature, and just give it a moment. And this will be our lithium chloride, which is already measured out right here. All right, we have 21, looks like 21.5 degrees. Okay, and let me dump it with water in here and give this a little stir up. Okay, again, this is the lithium chloride. Remember, our first number was on there, our first temperature, initial temperature. And we'll just stir this, stir this, stir this. And still a couple chunks there on the bottom. Not sure if it's going to get much warmer than this. So we had about 36.2 was our highest temperature. Yep, about 36.2 degrees for that. All right, let's do our last one. All right, let's get our initial temperature. You see the temperature is going down to get our initial temp. And this is the potassium chloride, our potassium chloride. I'm not sure if the temperature is going to get exactly down to where it was before, which I believe was 21.5, but it might. Looks like we're just about there. Yes. All right, we hit our, all right, 21.4. All right, so we have our initial temperature for the potassium chloride, which is here, and we'll add our water into that. So our initial temperature actually is 21.1 degrees. Let's go ahead and add our water in there. Stir up. And you can see our temperature is slowly decreasing. We'll give it about another 10 or 15 seconds of stir rate. And again, for the potassium chloride, our new temperature, 13.8 degrees, 13.8 degrees. So that one definitely got much colder. So again, endothermic reactions and exothermic reactions. Endothermic, get cold. Exothermic, give off heat and become warmer. So that's a quick definition of the two.